So we're going to look at components of vectors. So we introduce this idea of what's called a unit vector. And it's very simple. It's a vector which has a magnitude of 1, hence the name unit vector. Okay. So every non-zero vector, you can have a corresponding unit vector. Basically, it's the vector that's in the same direction, but has length 1 instead of the length of what the vector actually is. That would be its corresponding unit vector. How do we calculate it? Well, it's very tricky. What you do is you get the actual vector and divide it by its length. And then amazingly, that turns the length into 1. And it becomes the unit vector. The symbol for unit vector is this, what do they call those? Carrots. Yeah, it's like the carrot symbol. Okay, but there are two special unit vectors that we know. Because when we break vectors up into components, we don't just pick any particular vectors. We like two vectors that are at right angles to each other. Now, we're going to be very convenient here and say, well, if they're going to be at right angles, we might as well make them horizontal and vertical. Just like we do with the number plane. We have the x-axis, which is horizontal, and the right. So we just stick with that idea. So OI, the vector OI, or I with a squiggle underneath, we tend to give that our horizontal unit vector, we call it. And the vertical one, we call J. So then we can get any position vector we like and break it up into two components. So there's our number plane. Let's say we've got the vector OP, so whatever coordinates P are, let's say they're X and Y. Well, the actual vector I'm going to call U. So U is OP, that would be its position vector, but I could slide it anywhere and it would still be U. If I was to write it as an ordered pair, just like we do with coordinates, that would be XY. I could write it as what we call a column vector, again XY, but this time we write it vertically, I suppose, instead of horizontally, like the ordered pair. Now, you'll notice there is no comma there, we don't need it. Because when it's vertical, it's obvious which one's the X and which one's the Y. When it's horizontal, the reason we put the comma there is so we can tell, oh, are you talking about the number 10 or are you talking about 10? You see, so it's important to have the comma when we write an ordered pair so we know, oh, that bit's X, that bit's Y. But we don't need it in the column vector. And if we break it up into its components then, we say, well, it's X times the horizontal vector and Y times the vertical vector. So we generally use I, and you'll notice that one doesn't have the caret on it because we understand it to be the unit vector in the horizontal direction, and J we understand to be the unit vector in the vertical direction. So if we wanted to find the length of the vector U, well, it's Pythagoras really, it's just the square root of x squared plus y squared. And if we had to find the direction, just like we saw in trig and things like that, it's always the angle we make with the horizontal. And so I can do a bit of trig and go, oh, that's the inverse tan of whatever y is divided by x. Okay. Equal vectors. Well, we saw this yesterday, that equal vectors, they have the same length or magnitude, and they're parallel, so they have the same direction as well. So there's one. Oh, I could put it there. I could put it over there. I could put it anywhere I like. It doesn't matter where I put it, the length doesn't change and the angle does not change. So that's the beauty of playing with vectors. But if at any time you want to work out what that vector is, its position vector, you go head minus tail. That'll tell you. So if we knew that this vector AB started at 0, -4, finishes at 3, 0, we could work out where the others are. Now AB, another way of saying that, is I could say, well, it's 3, 0, minus 0 minus 4, head minus tail, and that now tells me the position vector, 3, 4. CD, maybe, this one, maybe C's at -4, 1, and D's at -1, 5, but again, the head minus tail would give me 3, 4. So it doesn't matter where the vector is. If I go head minus tail, I'll get that position vector of 3, 4. So that we'll call P, the vector P. In component form, therefore, the vector P would be 3i plus 4j. So 3 in the horizontal direction, 4 in the vertical direction. And the unit vector for P, all we do is we divide it by its magnitude. Well, the length of 3, 4, I conveniently picked 3, 4 because that's a Pythagorean triad. We know the hypotenuse must be 5. So if I divide everything by 5, we have the unit vector of P. That'll do us for today.